Hello friends, welcome to Physics Live channel. Today we are discussing about mathematical physics second order differential equation. What do you mean by second order differential equation? That is order is 2 and degree is 1. And it's a function of d, that is a derivative with respect to x or any variable. So we can represent a general equation, that is ad square plus bd plus c into y is equal to 0. ad square plus bd plus c into y is equal to 0, where this d is derivative of uh, a variable. That is, if you are considering an equation in which order is 2 and degree is 1 and it considers the differential, that is d by dx. So we can represent a general equation, that is ad square plus bd plus c into y is equal to 0. And we have two types of equation, that is f of d y is equal to r, that is a function of differential is equal to r, that r may be 0 or not equal to 0. So 0 means a function that's equal to function of differential that's equal to r. This r may be 0 and cannot be 0. This 0 condition, that is known as homogeneous, and not equal to 0 condition, that is non-homogeneous. Okay, so we have two types of second order differential equations, homogeneous and non-homogeneous equation. Okay, so what is the situation of solutions of this homogeneous and non-homogeneous equations? So if you are considering a homogeneous equation, second order differential equation, the solution will be y complementary function. If you are considering a non-homogeneous differential equation, y solution become y complementary function plus y particular integral. Okay, so if you are considering a homogeneous differential equation, y solution become y complementary function, and a non-homogeneous equation, y solution become y complementary function plus y particular integral. So what is the condition? So if you are considering a homogeneous equation, we know that homogeneous equation, that is the right hand side of the equation becomes 0, that is ad square plus bd plus c into y is equal to 0. This is a homogeneous equation where d is the differential, d by dx. Okay, so y solution become y complementary. We know that for a homogeneous, y solution become y complementary function. And how to find this solutions? How to find the solution? For that we have to find the roots. We know how to find the roots, that is this equation equal to 0, and for a second order differential equation, two roots are there. To find roots, we know that minus b plus or minus under root b square minus 4ac by 2a by 2a. This is the equation for finding roots. Okay, so we get two roots, that is by the equation d is equal to minus b plus or minus under root b square minus 4ac by 2a. From that we get two roots, that is represented by m1 and m2. Okay, So we get two roots m1 and m2. And what about that solution, y complementary function? We have three cases. That is, these two roots are different. These roots are different and real. These roots are different and real. First condition, that is real and uh, different or distinct. So y complementary function, that's equal to c1 e raised to m1x plus c2 e raised to m2x. This is the solution, y complementary function of a homogeneous differential equation with the roots are different and real. If roots are same, that is m1 is equal to m2, y complementary function that's equal to c1 plus c2x e raised to mx. M means m1 equal to m2, that's equal to m. Okay, y complementary function is equal to c1 plus c2 x e raised to mx. This is the y complementary function for a homogeneous equation with the roots are same. Okay, and third condition, that is the roots are imaginary. The roots are imaginary. For that we have two roots. Okay, m1 is equal to alpha 1 plus I beta 1 and m2 is equal to alpha 2 I beta 2. What is this? This is a general representation of an imaginary number. We are considering 3 plus 4i or 2 plus 2i. Like that we have two uh, two imaginary root, that is alpha 1 plus I beta 1. Sorry, alpha plus I beta. M2 is equal to alpha minus I beta. Okay, two roots are there. These are imaginary roots are there. That is m1 and m2 are alpha plus I beta and alpha minus I beta. So these are the two roots. And what about the y complementary function? We know that we are considering the y, the roots are real. We know the y complementary function, that's equal to c1 e raised to m1x. m1 is alpha plus I beta x plus c2 e raised to m2x, that is alpha minus I beta x. Okay, so y complementary function is this, and we know that e raised to alpha is common for them. E raised to alpha x is common, so c1 e raised to I beta x and I beta x plus c2 e raised to minus I beta x. Okay, so this is something of, we know that by adding this, we know e raised to I theta is cos theta plus I sin theta. E raised to minus I theta is cos theta minus I sin theta. Okay, so by adding this, we get e raised to alpha x, some sort of constant, that is d1 cos beta x plus d2 sin beta x. Okay, d1 cos beta x plus d2 sin beta x. For simplicity, we have to remember that is y complementary function for a for roots are imaginary, that is m1 and m2, that are m1 and m2, that is alpha m are alpha plus or minus I beta. The roots are imaginary, and the y complementary function is equal to e raised to alpha x c1 cos beta x plus c2 sin beta x. So this is the general solution for a y complementary function, general solution for a second order differential equation with the roots are imaginary. So here we are discussed three conditions, that is for a second order differential equation it is homogeneous and the roots are same. Roots are same case is first one, that is the y complementary function, roots are real and distinct are the first case, that is y complementary function is equal to c1 e raised to mnx plus c2 e raised to m2x. And second case they are same, the roots are same, and the y complementary function is equal to c1 plus c2x e raised to mx. M are the roots. And third condition, the roots are imaginary, that is y complementary function that's equal to e raised to alpha x c1 cos beta x plus c2 sin beta x, where alpha plus or minus I beta are the roots. Okay, roots imaginary roots are there, alpha plus or minus I beta.